Good morning, students. Welcome to the next topic, that is magnetostatics. As we know that, again, magnetostatics is the magnetic field which is produced by static poles. In case of magnetic field, if you see, magnetic monopole does not exist like electric field. So as seen in the last section, that is, electric field can be produced by either positive charge or negative charge. That is, a single pole is responsible for electric field. However, in case of magnetic field cannot be produced either N or S pole. However, it is produced together. That is, N and S pole always they forms together. So if you break this particular bar magnet into two, then again you will find that if this end is S pole, then there will be a formation of next pole N on the side. And if this is the N pole, then there will be a formation of S pole on the in this side. And therefore, this is the truth that magnetic monopole does not exist. So, as like in case of electric field, we have one law which is called as a Biot-Savart's law, where magnetic force is given by F is inversely proportional to 1 upon r square. So here also magnetic field decreases as we move away from this particular bar magnet. So if you see this particular picture, then magnetic field is also represented by magnetic field lines. And from this picture it is seen that magnetic field lines are moving away from the N pole, they are emerging out from N pole, and they are returning back to the S pole. So magnetic field lines are entering into the S pole. And therefore, if you see here, actually this loop has not been seen as a completed loop, but however with very weak magnetic field, all these loops will get completed. So if you see here, these magnetic field lines, they form a loop. So it starts with one magnetic pole and it come back to the second magnetic pole. And therefore, with the help of this particular magnetic field lines only, we can understand logically how is the divergence and curl of magnetic field. So two expressions are written here. Already we have discussed divergence of electric field where we got a finite value for that. However, in case of magnetic field, del dot, that is a divergence, is 0. Why this is 0? Because all these lines, they happen to be, or they found to be, they are seen to be diverging, but they are not actually diverging in nature. These lines, whichever are emitted, whichever are emerging out from one pole, they will return back to the second pole. All the lines, they will return back to the second pole. And therefore, these lines are not diverging in nature. They are forming a loop. They are coming back. They are intersecting with each other. And therefore, divergence of magnetic field is always 0 in case of this particular static poles. So these are static magnetic poles. However, if you see now, you can easily understand that this curl of magnetic field, it has a certain value, it has a finite value. So why it has a finite value? As shown in the figure, it forms a loop. What forms a loop? Magnetic field lines, they form a loop, and therefore curl of magnetic field has a certain value here. This particular expression is also called as Ampere's law in magnetic field. So this is all for today. Thank you.